All right. So the time frame here, this is a 3 week time frame. I've just done a box plot there of the number of cases. So you look at that and you see, okay, there's no outliers. What I'm looking for at this point now is to get an idea of whether the process here is in statistical control. So let me say a little bit about what statistical control means. So statistical control is a term that comes from total quality management, and what it means is a process is in any kind of process. So the process here is the occurrence of new cases of COVID-19, and in the time period we're looking at here, this 3 week period, I would say that's in statistical control. So what that means is there's a certain amount of COVID activity, but it's not obviously going up or going down. It's fairly stable. There's a bit of noise. It sort of bounces around. So that, the median number of new cases is what, 3 or something like that, about 3. And it kind of bounces around. It gets up to sort of 9 at one point, and we know it gets down to 0 at another point. But it's not shooting up, and it's not sort of shooting down to 0 for any length of time. And what the way we use this idea of statistical control is like this. The objective of the government here would be to take that stable level, as it was then, of about 3.5 new cases a day, and push that down. I mean, ultimately, they'd like to get it to 0. And so what they would focus on, probably the main thing would have been a vaccination program, and maybe some other things, some education programs and so on. What we the way we think about this, though, is if we want to push something down or up, or adjust it in some way, a process, it's best to do that if it is in control, if it is kind of stable. It might be a bit noisy, might be bouncing up and down a bit, but within a limited range. So it's sort of manageable, and you can, if it's like that, then you can measure the effect that whatever intervention or change you make has. If it's out of statistical control, if it's shooting up or shooting down at a fast rate, or if there are lots of outliers, then you're not going to be able to make interventions and get feedback on the interventions in a very effective way. So the rule is, before you try to intervene to improve the kind of base level of a process, you first make sure it's under statistical control. You deal with the large fluctuations, the outliers, and so on. Now that's just a density plot of the same data. What that says to me, when I look at that says to me, yeah, that's typically the shape I would expect from random variation. That's roughly, what we call a normal curve. It's a little bit, we say, skewed to the right. This is a term that confuses people. I have to think about it twice quite often. When we say a curve like this is skewed to the right, what we mean is the long skinny bit is on the right and the fatter bit is on the left. And most people naturally, I think, would think that skewed to the right means the fat bit's on the right. But that is a slightly skewed to the right distribution. But it's not too bad. That's just typical of what I would expect from a fairly random process that's not going out of control. Now, please don't ever hesitate to interrupt and ask me a question, or put a question on chat, because if you've got a question in your mind, it's almost certain that somebody else in the class has got the same question, so I don't mind being interrupted at all. So I've done the usual 5 number calculations here, and in particular I've calculated the upper fence. So remember, this is the number that distinguishes outliers from non-outliers. And what we do with a run chart is we draw a line for the upper fence. And the reason we're doing that is just to help us identify outliers. So what I'm doing here is I've calculated the upper fence based on this whole set of data. So I'm taking the view with this that this first 3 weeks of May, the COVID process was in statistical control, and so it would serve as a reasonable baseline. Okay, it's a standard by which I can judge what happens in the future. So I've drawn that line at 12 new cases a day. So anything over that would be regarded as an outlier. And with statistical process control, there's quite a few different techniques we can use as evidence that a process is going out of statistical control. And one of those, the only one that we will deal with here, we'll do some others later in the course, but the one that we'll deal with here is simply the presence of outliers. So the way an upper fence works like this is the position of the upper fence, the way we calculate it, the practical effect is that you wouldn't expect an outlier more than 1 or 2 days a year if the process is completely in statistical control. So it's a fairly extreme test. You can have a process that's in statistical control, and you still may very occasionally get an outlier, but they're very rare. And if they start popping up much more regularly, then you pretty much know something strange is going on and you want to look at it. In a situation like this, in a pandemic situation, where one of the key features of infectious diseases, pandemics, is that as soon as they get out of statistical control, they tend to shoot up very quickly, and it's very hard to get them back down into statistical control. And we've all, I think, now experienced this. So even in Canberra, and we're only in about the 5th day or something of an outbreak, we had, one case on Thursday, I think, and then it had sort of grown to 3 or 4 on Friday, and it was about 9 yesterday, and it's 19 plus whatever, I think 19 new cases today. That's what they do. So if you're looking at a run chart for in a pandemic like this, and I've heard medical experts say exactly that's what they were doing. They didn't use the term run chart. They said they were looking at, use the term running averages, but that's what they were looking at. Boy, as soon as you see an outlier, what you do now is you lock down. That's what's happened in Australia. As soon as there's an outlier, boom, you get a lockdown. We had a new lockdown today in the Northern Territory, and that was based on one case. Okay, so this is our baseline. So what I'm showing you in the next chart here is I've added the next 7 days. So the things to look at here in the chart. The first part, you've got a vertical green line there. So everything to the left of that vertical green line, that's our baseline. That's this data here. And we just continue the upper fence line across the top. So in this next week, again, everything's in statistical control. It's all safely well below the upper fence. So that's nice. Now what we're going to do is going to look at, so this is 4 weeks of data. We're now going to look at 8 weeks. So when we look at the 8 weeks, left of the green line is our original 3 weeks of data, our baseline data. We've got the, we've got our upper fence line there at 12. And what you see is things are sort of bouncing along nicely under statistical control. And then when we get to about the 22nd of June, there's 19 new cases. We get an outlier. And then the next day we get another outlier. And then we get another outlier. And then we get another. So we've had four outliers in 4 days, when we would be expecting, if the process was under control, to have probably one about every 280 days. So that was immediately, well, that was cause for alarm. Those of you that are familiar with New South Wales, the New South Wales situation, will know that the state didn't go into a full lockdown right away. They did some other things for the first little period. But I think any medical expert who saw that chart would pretty much start to panic as soon as they saw one outlier. And once they saw 2, they'd be thinking, boy, this is a problem, and they would get going. Okay, so that's one example. These can be used in lots and lots of different situations. If you are, you can use. I've helped someone lose weight using a run chart. I'll actually give some data from that example later in the course, probably. You can use them for, they are commonly used. The most common uses of them, I think, are in manufacturing and logistics. But they can be used for things like regular customer satisfaction surveys, for monitoring activity on websites, on online shopping sites. There are many uses for these. Any situation where you've got a process and you want to either monitor that it's, be sure that it's not changing in a bad way, or a process that you want to improve, and you want to make sure that it's stable before you improve it or try to improve it, and you want to be able to check, to be confident that your attempt at improvement has actually worked. They're a really useful tool. There's another component to the use of them that I'll teach you later in the course that will sort of make them even more useful. But just even the business of being able to look for outliers can be useful in many situations. All right, any questions before I go on? Okay, so run charts are one thing that we can do with single variables, time series variables. They don't involve anything more than being able to calculate an upper fence, which you all know how to do now. Let's move on, and I've got quite a long section here in the notes about median smoothing. I don't really want to make too big a deal of this, but it's a useful technique that we sometimes use in exploratory data analysis. The typical situation is where we've got fairly noisy data, it's bouncing around a lot, and we're trying to see if there's an underlying pattern. Now, I'll just remind you that up till now in the course, and this continues today, I'm talking about exploratory data analysis. So what we're doing there is we're investigating the data, we're trying to build a picture in our mind of the shape of it, we're looking for possible causal relationships, hypotheses about causal relationships, but we're not doing any testing of causal relationships. You can't really do exploratory data analysis and say, aha, I found that something causes something else. You can say, hey, it looks like something causes something else, and then you can think about how you would test that. And testing it would involve collecting more data, typically, perhaps through an experiment and doing analysis. And we call that process, that kind of data analysis, we call confirmatory data analysis. And we will be looking at that in the course, but a little bit later on. So median smoothing is just a relatively simple technique for getting some of the noise out of data. So this here is our original bit of time series data that we were looking at, and that chart there is what it looks like if we apply median smoothing to it. So all it does is it takes out some of the noise, it smooths it a bit, and it tends to get rid of isolated outliers. So if you've just got a very, one outlier but not several in a row, it tends to take them out. So let's, often what we do is we superimpose them. So what I've done in that diagram there, let me enlarge that a bit, that just shows you, I've got in grey the original data, and then I've put the smooth line in a brighter blue colour.